Right, so we're back to the final stage of solving this problem. This study of a population with 4 million people, 0.9% carry a virus. Find the smallest sample from the population so that the probability of the sample having no carriers is less than 0.4. And we've found by applying the formula by hand, we found an equation down here that we can use to graph this problem. So we want to compare these two numbers. So 0.991 to the power of n to 0.4. We could solve this graphically to find our n. And this is what we want to find out, the number of trials necessary. So we could look at this in GeoGebra first, and then we could look at the calculator afterwards. If we graph this in GeoGebra, the first function, this is a power function, because you have a number to the power of x or n or the variable that we're talking about. If we graph this, it's going to look like this. And our probability level, 0.4, is just a number. So that's going to be a straight line, a horizontal line. And then we could find an intersection point between these two graphs. And that intersection point is going to be 101.35. We can do the same thing on the Casio, and that's really what is most relevant to you. So let's go to the, where did it go? Our calculator display. And let's just see how we're going to solve this here. Now, this is going to be a, let's see. Okay, yeah, I got all my keys here. This is going to be a graph. So I'm going into menu 5 here to graph this. I just want to delete the previous graphs I have. Just delete. And to enter a graph here, I just start typing, and this is going to be 0.991 to the power of x. Oh, hold on. To the power of x, like this. So this is the power button, and this is for the variable x. Okay, so that's our first function. And the second one is simply going to be the number 0.4, like this. And we could draw them. So F6, syntax error. Oh, I see what it is. It's this. So 0.4. Yep. And draw. Okay, now it looks like this. It's probably going to look different on the 9750, but I want to change the view window here. So I'm going to set my minimum x to -1 and the maximum x to 150, and minimum y to -1 and maximum y to 2. Okay, and let's try to draw it again, and now it looks a bit different. So again, you can see It's similar to the graphs we have over here. And if you press the shift button, you can see where it says gsolve. So graph solution or solving. And F5 gives you these options here. We are interested in the intercept. So this is the intercept is where the graphs meet. And the intercept is 101.35. Now, when x is 101, this power graph dips below the 0.4 line. So this is, that means that 101, that's not a big enough sample to get lower than 0.4. So the lowest sample we can have, the lowest sample is 102. So you need a minimum sample of 102 to, what are we supposed to find again? So the probability of the sample has no carriers, of having no carriers is less than 0.4. Okay, so this is how we need to work on the Casio. We need to find a graph solution rather than just using the binomial menu. So this is only the case when we need the inverse binomial distribution. And this happens when it's the sample size that's missing or the number of trials. If that's what we need to find, then we have to try to find the inverse. And usually that means using a graph solution by using the formula and drawing the graphs. You need the same techniques to solve all of assignment 12, especially the last question. So you can't simply use the calculator to solve that one. You have to use the formula and do a little bit by hand as well.